Every time you're using a computer, you are using an operating system, and that is the main software that keeps the computer going. But what is it? So, an operating system in the long run is just a software program. Nothing super crazy about it. That's all it really does. All right, now, when we take a little bit deeper look at it, there's the manager portion of the operating system, and we need to manage multiple things. We need to manage the hardware, so that would be the CPU, the RAM, the hard drives, the GPU, the specialty cards that you might have installed, keyboards, mouse, monitors, the list kind of keeps going on and on and on. So that operating system for when it's working on managing hardware is actually managing a whole lot of different, very complex pieces of hardware that it needs to manage and keep working and to have pull and get information from and do all these things at exactly the right times. All right, so there is a lot going on in the background when it comes to hardware. Next, we have software. So we have the operating system itself it needs to manage, and then it also needs to manage the extra applications and different softwares that you have installed. The web browsers, the games, the CAD software, graphic design software, calculator app, Outlook, whatever the list is. Again, it's a very, very large list that it needs to be able to manage. It also needs to manage multitasking. All right. The computers that we are using and most likely are used to using, they are doing a whole lot at the same time. You might be watching YouTube video, browsing the web, working on your homework, checking your email, doing Excel spreadsheets, whatever the case is. If I look at my computer right now, I have Firefox open, I have Excel, OBS, Spotify, PowerPoint, and Word. So it is managing all of those different applications on top of itself, making sure that everything's code is running at the right process and each getting a little bit of time itself and figuring out which core of my computer should be doing that. I have an 8700K, which I believe is a hyper-threaded 8 core. Nope, nope, that'd be a hyper-threaded 12 core. All right, so it's doing a lot of going on in the background when it comes to all that multitasking. And so it needs to schedule them. It needs to provide services to keep the scheduling working. It's just going on like absolutely crazy. All right. And the other question is it a single or a multi-purpose device? All right. Your traditional operating system, Windows, Mac, Linux, those are all going to be multi-purpose devices. So they don't have a very like one specific job that they need to do. However, there are some OSs out there like OpenWRT, which is a open source router operating system, and it is a single purpose. Its whole job is to do router functionality. All right, another example that would be pfSense. All right, so there's a little bit of going on there when it comes to those types of things. Now, when it comes to the role for your operating system, all right. There's basically three main roles that your operating system could be. It could be a desktop role, a server role, or an embedded role. All right. A desktop role is traditionally going to be a single user device. It is one person is going to be using that computer at a time. And when we say desktop, we're also talking laptops and things like that. All right. So it's single user, and we have that beautiful GUI that we talked about in the last presentation. If we move over to the server role, all right, now we are dealing with many things happening at once in the background. This is also could be a multi-user system, so you could have a whole lot of people logging on to that one server at the exact same time, and it's sharing all of its resources with all those people who are using it and all those services that are using it. Some examples of server applications that you might be using are print servers, web servers, databases, oh man, the list just kind of goes on and on and on and on. Video servers, those types of things. Like if you're using Netflix, that's a server running that in the background that's sharing that video with you. All right. Oftentimes servers are going to be run not they might have a GUI, but they're definitely going to be using the command line interface, that CLI, again, that we talked about in the last video. Another operating system role would be that embedded. All right, these are going to be small single-purpose devices. Basically, in theory, they do one thing really well. I'm putting really in air quotes, but you can't see me. All right, its job is to do one thing really well. In my opinion, your opinion, does it actually do it really well? And that's the questionable part there. We'll come back to some of these options later. So we have operating system life cycles. All right. So many of you will have said, okay, well, I use Windows 7, I moved to Windows 10, and now we're at Windows 11. That is going to be a upgrade cycle. All right. But before we get to that, we have the update cycle, and this improves the current version. All right, you've probably used many different operating systems and things like that, and then you're getting little updates here and there. All right, not a large major change, but it's just like improving things, making it less buggy, improving security, something along those lines. All right, and the big benefit here with updates is you shouldn't have any major compatibility issues. It's not like, oh no, we've gone from doing A to B and now our software doesn't work. Normally, that's not going to be a case with an update. Now, the upgrade, on the other hand, ooh, that can be a big, big difference. All right, that can be a very large change. Again, going from Windows 7 to Windows 10, that is could have been a complete rewrite of the software. Yes, it still has the same name, it still has the same job, but it could be completely rewritten from scratch. So things may or may not work like they used to. All right. Um, and there is a high likelihood that this will actually break something if you don't test it ahead of time. All right. And that is one of the downsides of proprietary software is testing is done, as they see fit and with what they think is necessary and those types of things. Um, and they only can test so many different variations of things. All right. So until they get it in the hands of real world users and, mass adoption, they're not testing all these edge use cases and things. So there's probably going to be some compatibility issues in the long run with that. So that is a bit problematic in the long run, but that's the only way it can go. All right. Um, Next, we have our release cycle, and this is for OS and software updates. All right. How often are we going to release things? All right. For Windows, this is traditionally every few years they go from one version to another. I think Windows 10 was supposed to be the end-all version of Windows, and we're never gonna change it again. We're just gonna keep updating this. And well, what happened? Windows 11 came out. All right. So what is the release cycle? And this is both for operating systems as well as software. So this could be as simple as monthly, or yearly to multiple years down the line. And everything is going to have some sort of life cycle, and that is how long will the software or the operating system be supported. And the thing that we care most about support is security, right? We don't want our software that we're using to be 20 years old, and someone finds a crazy security flaw in it that you just type in some silly little command or whatever, and it just spits out all your passwords and things. That's not something that we want. Um, so it's costly to maintain software. Right? It's not just, oh yeah, we make this once and we're done, we forget all about it. No, you have to constantly take into account security issues and are we going to add new functions and whatever the other case is. So that life cycle is going to be very important. But again, security updates are the most important. I'm also, again, supporting it for newer versions of operating systems and things, but this whole presentation is about it. Last, we have compatibility. Can older software still run on the newer versions? Right? Your company uses software A, and Windows 11 doesn't support software A anymore. Now, is that Windows 11 fault or is that the software company's fault? Well, it's a little bit of both. All right, Windows 11 might have changed something drastically that caused the software to break. So in that case, it's Windows' fault. Same point, the software company has to update their software so it can work on the newer operating system. So it is definitely a bit of a give and take here. This may or may not also be important to you. You may not care about older software running. You're like, well, we're only ever running like Office and things. So the newer versions are always going to come out and take care of all those compatibility issues. So that may or not be a problem. Now, a lot of the better operating systems, Windows 11, newer versions of Mac, they have virtualization capability. So they can virtualize themselves to make them run software think they're running in an older version. So if you didn't know that, you can actually right click on a launcher for a program on Windows properties and do compatibility. And you can say, yeah, run it like it's Windows 7 or Vista, or I think you can go back to like 95 or something. So it actually allows you to tweak things to make it hopefully run better in the long run, which is really kind of nice. Stability is also going to be something we need to worry about. So we have, as far as I'm concerned, there's four major stages of this. So we have pre-alpha or MVP, minimum viable product, and this is what's happening during the software project development. All right, so this is, okay, we've got this idea, we're going to start writing code. We are testing it on our one system. Not a lot of testing going on, so we're just working on it, trying to improve it, getting it better, getting it stable, making it work on our one system. All right. And then once they're happy and they're like, okay, this is stable on our system, maybe we check in on a few other systems that are around the office, or whatever the case is. If it's for a phone, maybe we have everyone in the company download it onto their personal phones, or whatever. So we got 20 different phones now we could test it on. And we're like, okay, this is working on all those. That's when we start getting into the alpha stage. And this is not going to be a thoroughly tested. It's going to have a lot of bugs. Again, may only have been tested on a few system variations. Okay? And there's may still be development and features to go, but it's at a point where it's like, well, we got to start testing this. So it goes into alpha stage. Now, after it's been in alpha stage for a while, and we're pretty happy with the features that we've got, those types of things, then we start getting into the beta stage. And at this point, there may be some known or unknown bugs. All right, so we may go, okay, we know this is a bug. We know we're having problems with this. But that's not going to keep us from testing this on a larger scale. So we get to the beta point. Traditionally, betas are they can go the whole gambit. They can be very stable and work beautifully well, depending on how long they've been beta, or they can be just barely out of alpha, and there's still a lot of bugs and things that need to be dealt with. So, one of the big things happening in the beta stage is testing for compatibility of different things. And once everything is, we believe, all of the bugs are dealt with, or at least the bugs are at an acceptable level of being dealt with, there may still be some bugs that you're like, well, this is going to happen. It's going to crash the software. We know that it's an acceptable problem. If we can deal with that after the fact, is basically what it comes down to. So we've passed all phases of verification, and basically it's saying, hey, this is a very stable and capable for anybody who uses it. Basically, this will work on almost any Windows computer that's Windows 11 and meets these requirements, or whatever the case. So that's when we get to that stable release phase. And again, this also goes for operating systems. Basically, it's like, okay, this will work on any hardware that it can basically be installed on, type of thing. Now, when it comes to the cost of different operating systems, all right, there are a few things that you need to take into. First is licensing. All right, licensing software can be silly expensive as far as I'm concerned. And I keep mentioning software, and again, the operating system is basically software. So right now we can probably, overall interchange software for operating system. But so licensing can be very, very expensive. I think a normal license for Windows is like $100 unless you find it on a deal or something like that. Now, to you and I, that might not be that much money, but to large corporations, they have a different licensing system for their operating systems than we would have as individuals. So that licensing software can be very, very high. All right. Then that also leads you into support. Now, depending on what licensing agreement you signed, your support could be covered by that licensing fee, and that might also be why that you have such a high licensing cost. Um, However, you can also sometimes buy external support. So it may be, okay, Windows, their support, it's fine, it gets most of the job done, but it takes them a week to get back to us. Well, we need something quicker than that. So we're going to pay a little extra to another company, and they're going to be able to get back to us within a day or within an hour or whatever the case that is. When you get to this like open source software, again, like Linux, oftentimes you don't have that person that you can contact at the company that supplied the software, because it could be a small person, small company, or just a single person, and they don't have time to do support tickets. So you may have to have an external company for support if you want it. Right. You also have your hardware costs for your operating systems. So what type of processors you're using, RAM, motherboards, how many of them are you using, those types of things. What type of future requirements do you have to think about? How right now we're only the small little 5-person company. In a year, how big are we going to grow? Those types of things. And then last, you have to think about your staff resources. All right. Again, your support could be local. You could have a dedicated person who knows this system inside and out, and all different aspects of it, yada yada yada. They are an expert themselves on this software. So that could be all the support you need, not just the staff that you have, but you also have a lot of other staff that may be using this. So there's a lot of different things that are going into the costs of this different software. Now, the first, probably most popular operating system out there is going to be Microsoft Windows, or at least the most well-known. I don't know if it's truly the most popular, but it's definitely the most well-known. All right. There are desktop and server versions of Windows. We are currently on desktop version Windows 11, and then we're currently on server, which is, I think it's like Windows Server 2022. That's a very unique name, but I think it's just like Windows Server 2022 is the name, and that is as of making this video. So there is definitely a server option there for you. We also have release schedules. So for Windows, it's basically every few years. They go, okay, we're going to have Windows 10, and then this year we're going to release Windows 11. And just every few years they are putting new versions of Windows out there, both server and desktop versions. We have compatibility, and Windows is pretty decent for backwards compatibility. It does have virtualization that can make it work, so it's definitely a pretty decent option there. Now, we also have cloud options, not directly for normal Windows operating systems, but Microsoft has cloud servers. I believe it's the Azure, Azure. So you can actually say, well, I don't want to have a server running at my actual job, so we're going to put it in the cloud. So you can rent server time from Microsoft for whatever tasks it is that you want to use. And as an individual, this isn't stupidly expensive. It might be a few bucks a month or something like that for you to do some small scale stuff. But when you start getting into the very large things and that type of stuff, it can become very costly for you. So, another popular operating system is Mac OS. So this is partially based on the FreeBSD Unix software. All right. So yeah, it is. And the FreeBSD is an operating system used to power modern servers, desktops, and embedded platforms. So it is partially based around that. Unix, this is officially Unix certified. It passes all the qualifications that it needs to be certified as a Unix system. All right. Now I put this one in quotes, easy to use. All right. This is definitely a user opinion. Do you like how Mac OS works? Do you not? Obviously, the more you use a different operating system, the easier it becomes to use for you. So maybe the better thing would be easier to learn, might be the better way to phrase this. So when you need to teach someone, how to do something on a Mac, it might be easier for them to learn how to do it than compared to the Windows alternative. It also, I would say overall, probably just works a bit better than Windows. It crashes less, programs freeze a little bit less often, those types of things. Some people love Mac OS, some people hate it. It really comes down to your personal opinion. And back to that easier to use, you do have less control than you do in Windows. Windows, you can, if you really want to, you can get into the Reg editor and make tweaks and changes, and you can really make Windows work for you if you know exactly what you're doing. But if you don't know exactly what you're doing, it can also lead to a lot of headaches, because if you change a file that you weren't supposed to change, ooh, that's just a bad day. So it's definitely a little bit of a give and take going on there. There is a server version of Mac OS, but from my understanding, it is basically not used today. The only real benefit to it is if you're managing a lot of iOS devices, so a lot of phones or tablets or things like that. I guess if you have a whole company of Mac computers, that it is good for that as well. But from what I was reading, there is good alternative softwares that you can run on Linux or Windows servers to manage those devices just as easily. So a little bit of give and take going on there. And lastly, for Mac OS X, it's used by a lot of creative industries. All right, so if you're a graphic designer or video editor or those types of things, a lot of people absolutely love Mac OS for that. I know our photo people are, our graphic designers and things like that, HCC, are definitely big fans of the Mac OS, and that's what they have in their labs. So a little give and take. And the last thing I say for Mac is it has a lot of fanboys. There you have people who are die hard. Mac is the best thing ever. Why is not everybody using it? People, and they have their right to do that if they're really that big of a fan. My biggest request, if you are one of those people that's like Mac is the best, you got to give other options a chance. All right. Personally, I have nothing against Macs other than their cost. I think they are overpriced for what they are. But you may be saying the support and lifespan and things like that cover that cost. And again, that is your personal opinion, and I can't argue that too much with you. But I just think for what the hardware is that you get and the capabilities, it is a very high priced computer compared to that of a Windows or a Linux alternative. Next, we've got Linux as our last operating system. Well, it's kind of that we're covering. Linux is, you're basically never going to find this pre-installed on something, all right, especially like consumer grade desktops, maybe servers, you're going to find it pre-installed. But on a computer grade desktop or laptop, you're not going to find Linux pre-installed. So you have to do this yourself. Now this goes kind of goes along with those distributions that we talked about earlier, and I think part of that might be why it's not pre-installed is you have to pick which distribution is right for you. I can say, yeah, here's Ubuntu, we're going to pre-install it, and actually Dell did that for a while. And if you remember a few minutes ago, I just said that on Windows, I think the license was like $100 or something. Now again, when you're buying in bulk for installing on consumer equipment, that licensing is obviously going to go down from Windows. But when back when this was an option, I actually looked into it, and it didn't save you any money on your laptop or whatever that you were buying if you chose to have Linux installed on it. It was the same cost as having Windows. And to me, I'm like, well, then put Windows on it and I'll install Linux myself and I now have a Windows license. It doesn't work so well anymore with Windows 11 and how they do their licensing, but back then it did. Um, so, yeah, a little bit of give and take going on there. But for roles, there's a lot of options for what you want to do. If you want to have a server, you can do that. You can do traditional desktop. You could do a network router with using the pfSense distribution. You could do supercomputers. You can do embedded systems. So there's a lot of different options when it comes to Linux, and a lot of capabilities, again, for small and large systems. Another great example of a role for Linux would be the Raspberry Pis. These are little computers about the size of credit cards or, small cell phones and things like that. But it was a low cost computing device. I think it was originally like $25 or $35, and it allowed you to have a computer that you could program and had a GUI. It was a little slaggy in the beginning, but it's gotten a lot better. But it also had command line interfaces and things like that. So there was a lot of capabilities there. For life cycle, many distributions have major and minor update cycles. So this is going to be fixing bugs and features and things like that. So again, just kind of like Linux, you can do short-term little updates, and then every once in a while you have to do a large upgrade to the next OS, the next version of it. Again, you can stick with the older one, but the problem is they're not providing security updates anymore. So a little bit of give and take going on there. You have those enthusiast distributions. Those are designed for those who want to play. You never know what will happen to features or software that may stick around or disappear in the next update, but they also have fast update cycles, so they're constantly getting updates. All right. And then you have the enterprise distributions. Those are the exact opposite. They're going to be a slow update cycle. Stable and consistent is the game. Anytime you get into the wonderful world of enterprise, slow and consistent for software is what you want. You don't want something that's constantly changing, because things that are constantly changing break. All right. So they'd much rather have a nice, slow, consistent operating system, not slow operating system, but slow update cycle. So that way they can keep it working for as long as possible without having to put a lot of money into support things. Typically, your enterprise distributions will have support from anywhere from 5 to 13 years. That's a long time in the world of computers, 13 years. You might have even updated the hardware before that. I mean, 5-year-old technology for hardware is a huge step back compared to what it would be today. So I wouldn't be surprised if you're having new hardware but might be running the same distributions that you were running for the purpose of cost savings. We also have the stability things. So we have stable, testing, and unstable. We kind of talked about those in a little bit ago. For cost, your cost for the Linux is probably going to be zero or very cheap for the actual software license and OS itself. However, again, for support, you're going to be paying. That's where the money comes in. And then we talked about distributions I think it was the last video. So there's a lot of distributions out there. A few quick examples of distributions, just as a reminder, if you didn't watch that last one. Red Hat, SUS, Debian, Ubuntu, Kali, Mint. Again, there's a lot of different distributions out there. And then last but not least, for OSs, we have our embedded systems. All right, so over here on the right, I've got a whole bunch of embedded systems. We've got ATMs, we've got printers, we've got time machines, soda machines, vending machines, scales, point of sale systems. So they're going to be a smaller size for the actual computer. They're going to also have very low power consumption. We don't want to waste a lot of energy on these things, because that just ends up costing a lot in the long run. They are designed for a very specific task, and they are, in theory, again, air quotes here, great at that task. All right, they get that task done, and that's all they can do. They're not really designed to do anything else. And these things are used everywhere, as you can see. But many of these things you probably see on a daily basis and don't even think about it. Some other examples where you might see embedded operating systems are smart TVs. We're starting to have appliances like your oven and your dishwasher and your clothes washer. Those are all starting to become smart devices as well. Not sure that's the best thing to be making smart and connected to the internet, but we are getting to that point where basically everything is starting to have some sort of embedded operating system in it. And again, that it can make our lives simpler and also can make them a lot more complex. So that's a kind of a quick overview of different operating systems.